So let's get some numbers up here so we know what we're talking about. It says the satellite, actually it's not a satellite in this one, they talk about the International Space Station. So this book's actually slightly up to date. I worked out of a textbook once that talked about Skylab. Yeah, it's not up anymore. 240 miles above the surface of the Earth. And we talked about memorizing for most of these problems with the distance to the horizon, the radius of the Earth, which is roughly, how far? 4,000 miles. So that means this distance over here is also 4,000 miles. And then we had one more rule that we have to use in all these problems. Right angle between the tangent and the radius. So that means that right here there's a right angle. So I'm really looking at a right triangle now. A couple of things. There's first the rule that says all tangent lines are right angles to the radii, which you want to make part of the practice. When I was talking to another teacher yesterday, we pretty much agreed that every problem has a tangent line in it and a radius. So you have to label those guys in there. The second way you know that it's a tangent is that from the story of these problems, if I'm looking at the sight distance from any point to the horizon, I'm looking at a tangent line. So those are always going to be tangent lines there. And so that also then sparks that memory of tangent line, radius, perpendicular. So what I'm looking at then is a right triangle looks like this. There's my right angle. It's 4,000 on this side. It's 4,240 on that side. And that's the side I don't have.
Oh, I thought you didn't have C for some reason.
Yeah, and that's a lot of people will do that, especially out of habit, because that's what we tend to do is we give you the two legs.
Like I even drew it just like that, but I don't know why I did.
Yeah, well, it's a habit. That's the hardest part of the Pythagorean theorem is remembering when you're using two legs to find the hypotenuse, or when you've got one of the two hypotenuses, one of the legs and the hypotenuse, and you want the other leg. So now I'm doing 4,000 squared plus b squared equals 4,240 squared. Algebra ensues, and you end up at b is equal to 1,406 miles. Yeah.
I'm confused with the horizon concept.
The horizon concept?
Like, what does the question read?
The question said, and I quote, the International Space Station orbits the Earth at an altitude of 240 miles. Check. What is the distance from the space station to the Earth's horizon at the to the nearest mile? And that would be this pen. This distance right here is the distance from the station to the horizon. The idea is, as we're looking at the Earth, we can look at all these points along Earth's surface. So the question then is, where would the horizon be? And that's what we're going to be right out here on this tangent line.
So the horizon is like the tangent line?
Right. When we're looking at the horizon, we're looking at a tangent line to the Earth. We're looking at a point right where the Earth curves away from our vision, which means if we could keep going on there, we'd be then going off into space. Yeah.
Okay, so I did all the algebra that was supposed to go to it, and my answer is not intense at all.
Uh-oh. All right, rather than simply saying algebra ensues, let's ensue some algebra.
Well, I just looked up the calculator. It says 3.9 something and a bunch of stuff, and then on the very side in small it says 12.
That means, okay, if your calculator has number,
It's like to that power, right?
not to that power, it's 10 to that power. So if you have 3.647, and then over here in small print it says 12, that's the calculator's way of saying 3.67 times 10 to the 12th. Yeah. Now the only reason I want to comment here though is that means we're working with numbers that are really too big right now, I think. Because 4,000 squared is 16. It fits on my calculator screen. It's a big number. 16 million? Yeah, 16 million. Yeah, and that's what kind of makes it worth pausing to go, wait a second. Because you shouldn't be getting numbers on the order of 10 to the 12th.
Maybe my squared and my final number, because like the square root and the square number are right next to each other.
Yeah, that's possible. In fact, on a lot of calculators are even above each other. You have to push the second function first and then to get the square root. Yeah, and this is 42. 40 squared is roughly 18 million. It's 17,97760. 0. So from that, I subtract 16 million. And that gives me b is equal to, b squared is 19,77600. Doop. Doop. And then take the square root. And that's what drops you at my 1406. Yeah. And if it's little calculator errors, we're in pretty good shape. But you still want to watch for those. What else can I say about this fella? Okay, cool.